Okay, so I found this question on the Wyzant Ask an Expert. It's a pretty fun discrete math question, so I figured I'd make a little video on how to solve it. It says find a polynomial s of n such that s of n is the sum from I equals 1 to n of I squared minus I. And then it wants us to prove that the polynomial is equal to the sum for all values of n in the positive integers. First thing I'm going to do is we're going to rewrite this as the difference of two different known sums. So let's do that. Now these two sums are known. As the first one, we know that that's going to be n plus 1, and 2n plus 1 all over 6. And the second one is n plus 1 all over 2. These are well known. Okay, so let's just move on. Let's combine these two. 6. Okay. So if you notice, we can factor out an n times n plus 1 from both of these two terms here. Okay. 2n plus 1 minus 3 is really just 2n minus 2 over 6, which is the same thing as n minus 1 over 3. Use the difference of squares rule to rewrite this as n squared minus 1 over 3. And then finally, I'm going to distribute that n. So we have n cubed minus n over 3. And there is our polynomial. So we're going to use a proof by induction. Okay, so just recall that a proof by induction means that this will be true if it's true for the n plus 1 series. The sum from I equals 1 to n plus 1 of the given sequence, I squared minus 1. If it's true, then this should also equal the n plus 1th term. So n plus 1 squared minus n plus 1 plus, because this is a sum, plus this polynomial that we figured out in the previous step. N cubed minus n over 3. And that comes from this over here. If we add this to the original series that we were given here, it should equal the same value as if we were to plug in n plus 1 to the polynomial. So n plus 1 cubed minus n plus 1 all over 3. We just need to prove that this left side of the equation is equal to this right side of the equation. Okay, so let's go ahead and let's do that. This n squared plus 1, I'm going to go ahead and expand that out. And then I'm going to distribute this negative. And then I'm just going to bring down this n cubed minus n over 3. I'm going to do the same thing over here with n plus 1 cubed. And again, distributing the negative all over 3. This plus 1, this minus 1 is going to cancel out here and here. I'm going to rewrite the terms on the left side. You could combine these two, but I want to leave them separated. Again, starting with my largest degree term, n cubed. 3n squared divided by 3, that's just n squared. 3n divided by 3, that's just n. And negative n divided by 3 is negative n over 3. And these two are equal, so this has been proven.